So, what if I told you there's a new way to plan those massive, multi-billion-dollar energy projects? We're talking about a completely new AI approach that's not just a cool idea anymore, it's actually happening. And believe me, it is fundamentally changing the game. Okay, just picture this for a second. You are in charge of making a multi-billion-dollar decision, and all you've got to go on is data from miles beneath the Earth's surface. We're talking about a project that's going to run for decades. The stakes? Absolutely massive. The data? Insanely complex. The pressure is just immense. So how on earth do you make the right call? Right. So before we jump into the super cool AI solution, we really need to understand just how big this problem is. And everything, I mean everything, revolves around this one key document. It's called a Field Development Plan, or FDP for short. And listen, an FDP is so much more than just some piece of paper. It's the master plan for the entire operation. It lays out all the engineering, it predicts all the economics, it details the whole environmental strategy. It's basically the architectural blueprint for a project that costs billions and is going to be around for decades. So yeah, getting this plan right, it's literally everything.
You know, the whole process has these 4 big phases. But the real headache, the place where everything grinds to a halt, is right in the middle, in these select and define stages. See, this is where the teams have to sort through just an insane number of options. And every little decision, I mean, should we drill 5 wells or 7? Should we use this pipeline or that one? Every tiny choice sends these huge ripple effects through the whole project. And trying to figure all that out by hand, it's pretty much impossible. It just takes forever.
So how in the world do you deal with that kind of complexity? Well, this is where the big idea comes in, a totally new way to use AI to solve this puzzle. Now, we're not talking about some single giant AI that's supposed to know everything. Forget that. Instead, I want you to picture an entire team of specialist AIs. It's this approach called Agentic AI. And honestly, the best way to think about it is like having a digital board of directors. You've got different members, each with their own special expertise, all working together to crack the problem. All right, so let's meet the team, shall we? First up, you've got the FDP chief agent. Think of this one as the CEO or the project manager. Then you've got your specialists. There's a reservoir agent, that's your geology expert, and a facilities agent, your engineering guru. But here's the really cool part. They all work together on one single, shared, live model of the project. It's called a digital twin, and it's basically a perfect virtual copy of the whole operation, where they can test things out in real time. And this really shows you the night and day difference. The old way, it was all manual, everyone was in their own little silo, which of course means it was slow and, yeah, full of human error. But this agentic AI method, it's totally integrated and automated. So instead of some static plan that's basically useless the second you print it, you get this living, breathing system that's always learning and always adapting. Okay, I know what you might be thinking. This sounds a little bit like science fiction, right? A team of AIs, a digital twin? But it's not. So let's pop the hood and see how this is all built on technology that's very real, right now. I mean, it's a totally fair question. How can an AI agent actually become an expert in something as mind-bogglingly complex as subsurface geology? This isn't just about teaching an AI to spot cats in photos. We are talking about some seriously heavy-duty physics, geology, and engineering. Well, here's the secret. The AI agents aren't starting from zero. The whole idea is to train them to master the exact same super sophisticated software tools that human experts are already using today. You can think of it like they're becoming the ultimate power users of the best tools on the market. Just look at this table for a second. This is just a tiny, tiny sample of the kind of stuff this software is juggling. You've got things like relative permeability, which is just a fancy way of saying how easily oil or gas can flow through rock, or fault transmissibility, which figures out if the natural cracks way down there are going to help you or hurt you. A human engineer has to tweak these things one by one. But now imagine an AI agent that can adjust hundreds of these variables, all at the same time, to find the perfect, most optimal combination. It's a game changer. And get this, the software itself already has these incredibly powerful strategic engines built right in. These are just really smart optimization algorithms. The best way to think about it is like a race car engine. For years, the human expert has been the driver, but now the AI agent is learning to drive that car, and it can test out moves and strategies at a speed that is just inhuman. So what's the bottom line here? What actually happens when you let an AI take the wheel of this complex machine? Well, a prototype was built to answer that exact question, and the results are, well, they're absolutely staggering. The goal was pretty straightforward, but super important. They took a real-world task, which was evaluating 40 different development scenarios for a gas field, and they built a system to see if they could automate the whole thing. And this is what the raw data looks like. For every single one of those 40 scenarios, you get a table just packed with dense, complicated numbers. Normally, some poor human analyst has to manually drag all of this data into giant spreadsheets just to even start to make sense of it all. So that manual process, documenting, processing, analyzing all 40 of those scenarios, it took hours. We're talking long, tedious, painstaking hours. With the new system, using a custom Python library, that prototype did the exact same job in seconds. Let me say that again, not minutes, seconds. The jump in efficiency is it's almost hard to wrap your head around. But here's the real magic. It's not just about being fast. The system takes that ocean of raw data and turns it into a simple, interactive dashboard. It lets the human expert see all the trade-offs instantly so they can make a much smarter decision. It's all about turning pure complexity into crystal clarity. Okay, so let's zoom back out for a minute. What does all of this really mean for the future of making these huge, complex decisions? Well, it really boils down to 5 main pillars. You get real agility in a process that's always been slow. You get continuous optimization, which means the plan is never finished. It's a living thing. And maybe the most important part, you get a system that actually learns. It gets smarter and smarter over the entire life of the project. And the final word from the research team says it all, really. I'm quoting here. This project successfully validates the foundational concept that an agentic AI approach can significantly enhance the efficiency, robustness, and agility of field development planning. In other words, this isn't just a theory anymore. It works, and it's going to make a huge difference. And that really leaves us with one last big question. We've just seen how a team of AIs can help pilot multi-billion-dollar energy projects. So if AI can bring this kind of clarity and speed to a field with such insane stakes, what other complex system is it going to redesign next? Think about it. Finance, city planning, logistics. The possibilities are pretty much endless.